Everyone have a copy of the notes? Everyone have their book open, Sharpie? There you go. Alright, so yesterday we were comparing linear equations, right? What were the two things that we compared with them? Slope and y-intercept, that's right. So today we'll be moving on to comparing quadratic equations. And for quadratic equations, there are three things that we can use to compare them. First thing is by finding our minimum or a maximum. Minimum or maximum. Second one, by finding distance between our x-intercepts. And then the last one is by finding an average rate of change over an interval. So, when we're talking about quadratic equations, what's the minimum or maximum? Isaac?
Isn't the minimum like how low it goes and then the maximum is how high it goes?
Mm-hmm. So, we have two ways that we have quadratics, right? We have ones that open up and ones that open down, right? So, for ones that open up, what do you think we're going to have, a minimum or a maximum? Minimum, because right here, this is as low as our equation goes, right? How about for ones that open down? Maximum, that's right.
Where do we get that from? What's that point called?
What's this one? Very
Point right there.
highest point. Vertex. Vertex. Oh gosh.
Which part of the vertex? X value or the Y value? Wait a minute. Up and down, are you kidding me? X's go up and down?
No, why not?
Oh, Y value, okay.
Alright, so, yes, Trey.
That, right there, do you think we should write that down on our notes? That minimum, maximum thing?
Not yet. Once we get down here, I'll draw little diagrams of the problem that we're going to go through. Okay? Alright, so, example 3 on page 662, that's what I had you guys open your books to. It says that students in an engineering class were given an assignment to design a parabola-shaped bridge. Two students, their plans are to the right. It says Rosetta's plan and Marco's plan. We are going to compare their minimums and maximums, x-intercept, the distance between their x-intercepts, and the average rate of change over an interval. So, right here we have Rosetta's plan. What's written in our book? What does it tell us our book is? It just makes sense.
How is Rosetta's plan represented? Do they give you an equation? Do they give you a graph? What do they give you? A table?
And what is the equation?
Y equals negative 0 x squared.
You all have it. Write it down.
Yeah.
X squared
X squared
plus 1.2x.
1.2x. Alright, so we're dealing with bridges in this example, right? Are we or not? Yeah, we are. So, what kind of parabola do you think it's going to look like? This one or this one?
That one,
This one?
yes.
Right, so here's where we can draw it. So now we have a rough sketch of what our bridge looks like. It's going to open down, right? Then we have Marco's plan. How's Marco's represented in the book?
Graph.
On a graph. So we can say, yep, on graph. And we know what that one looks like. So there's a picture right there, right? So that one opens down too. So, when we're interpreting Minimums, maximums, what do you think we're gonna be dealing with, minimums or maximums?
Maximum.
Maximums, so maximums represents the what point of the bridge?
Highest.
The highest point, that's exactly right. So when we're comparing maximums for these bridges, what are we really comparing? The height of the bridges. We're gonna be saying if Rosetta's bridge is gonna be higher or Marco's is gonna be higher. Hmm?
I just made it for, I think Rosetta's gonna be
So you're predicting,
yeah.
okay?
Alright. So, in order to find the maximum for Rosetta's plans, that's the one we're gonna be dealing with first. We have to write down our equation for it first, so we have
Oh, negative 0.1.
okay,
B is 1.2, that's 1.2.
alright, so a long time ago, you guys were dealing with quadratic equations, right? And you were finding their vertexes and axes of symmetries and things like that. So right there, that might look familiar to everyone. That's how we find our vertex. So we identified our A and our B. So now we just substitute in our values. Over 2 times. This the basic look of it is negative b over 2a. So you could think of, we're putting this in parentheses, we're just substituting the value of b. Alright, so what is negative 1.2 divided by negative 0.02?
60.
Say that again, Trey?
60.
60. Alright, so that means what?
In other words, what did we just find? We found the what part of the vertex did you just find?
That's it.
No, which part, the x value or the y value?
The one.
I know formula starts out.
The X.
We found the x value, so x equals 60 is what we should put.
Right, so next thing, we substitute what we just found, and that was 60, in for x to get which value, x or y?
The Y.
Y value.
Put your y equals in front of that.
Thank you.
we just substitute in our x values and then multiply everything out. 60 squared is 3,600. What's 3,600 times negative 0.01? Negative 36. Then we have plus 72. So what's negative 36 plus 72? 36. So what did we just find? Right. We just found the y value of our what? Vertex. So based on that, if you found a y value of 36 and we're dealing with Rosetta's plan for her bridge, what is that 36 tell us? So yeah, you're getting there.
It shows us the coordinate where both the x and the y meet. So the tip, where they.
Let's draw a picture. Let's draw the arch right beside your word there.
Okay.
Let's put a vertex on there. Let's get the ordered pair name for that vertex we just found. What is that vertex? Ordered pair what? 60, 36, okay? So, what is it we were looking for again? We were looking for
The highest point.
the highest point. So how high, what's the highest Rosetta's bridge will go?
60, 56.
No, only one of those. Which one?
60.
Oh, okay, be careful.
No, 36,
Why?
because that's the y goes up and down.
Yep. Rosetta's bridge is only getting, its highest point is going to be at 36 feet.
Maybe we should write that in the arch, 36 feet high.
All right, so, is anyone not done copying what we have so far? Okay, now, we're moving on to Marco's plan for how he's gonna build that bridge. And we just have a graph for Marco's plan in our book, right? So how do we find the vertex from that?
Can we analyze the graph?
Yep, go for it. What do you see from the graph?
It looks like it's at 45, 24, it's only 25.
So just above 24, that one tick mark? All right, so can we know exactly what the height of Marco's bridge is? No, not really. So we can just say, estimate that Marco's bridge is approximately how high? About 24, 25 feet.
We said 24.5?
Nope, 24 or 25 feet. All right, so we found how high Rosetta's bridge is going to be, and we found out how high Marco's bridge is. So now we have to write a comparison statement about both of them. So what is a statement that you guys can see right away about both bridges?
That, Rosetta's bridge is higher.
Rosetta's bridge is higher. All right. So, oops. Rosetta's bridge is higher by how much? By about how much?
10, 11.
Bridge. Oops. About how higher than Marco's?
9, that's 9 and 10.
36 minus 24? 12? Because we're looking for the difference of height, right? So if she is 36 feet high and his is 24,
It's about 13 to 12 feet.
there you go. It's about 12.
Well, 25, take away from 36 is?
Um,
It's
No.
12 of them.
36 minus 25.
11.
There it is.
They need to show that in their work.
So for ones where you're given an equation, you'll have to show your work for finding the vertex. For ones that are given to you in graphs, you can just say things like estimates from the graph. So you won't have to show work for the graph part of the
I
problem.
think the best way to say to them right now, so we don't have to go through all that, is whatever we're showing in the notes, you need to show in your homework, okay?
There you go.
Let's do it like that. Sums it up easily.
Yep.
Use your notes.
All right, moving on to the back side of the notes. The second way we can compare quadratic equations is by finding the distance between our x-intercepts. So, if, I'm just gonna go back over here. Here is Rosetta's bridge, here is Marco's bridge. What do you think the x-intercepts would represent for a bridge? What? The distance. Yep. So where one bridge starts to the other side of the bridge where it ends, that is the total distance of the bridge. All right, so when we look at Rosetta's plan, she has y equals, she has this equation right here. We have to find, or what is an x-intercept again? What's the y value of an x-intercept?
0.
0, right? So we have to find out the values that make y0, yeah, y0 on their axis. So to do that, we have to factor out our equation. So what is something that we can factor out of both terms in here? What's common in both of them?
X.
X, exactly. So we factor out next, we bring it out here.
And we set it equal to what? We replace y with 0. Okay, remember when we were solving by factoring, we would replace the y with 0. Because then we can use what's called the zero product property, which says what? Anybody remember that? Set each factor, yep, set each factor equal to 0 and solve for x.
All right, so we set both of our factors equal to 0. The first one, x equals 0. Do we have to do anything with that one? Nope, we can just say that x equals 0 for this one. This one we have to do a little more work, right? So what are we solving for here?
X.
X, so what do we do?
Okay, 4.2.
Mm-hmm. So we're left with it. Next thing is, Yes, Brighton?
Divide both sides by 0.01.
Mm-hmm. All right, so negative 0.01 divided by negative 0.01. Anything divided by itself, it gives us 1, right? Then we have negative 1.2 divided by negative 0.01. What does that equal? What is that, Stefan? 60? So what did we just find here? Trey?
When x is 60, it's on 0.
So we're finding the x-intercepts, right? So we have x equals 0 and x equals 60, right?
I found like the vertex.
No, so we have a bridge here again, right? Cameron?
The two ends of the bridge go on the x-axis at 0 and 60.
All right, so we have one starting point here. What ordered pair would that be?
0, 0.
0, 0.
I got 120.
Raise your hand.
Call on him.
Malcolm?
Thank you.
Yes.
I got 120.
Did you?
I got
You got 122? So we should change this to 120?
Yes, sir.
All right. All right, so we got 0, 0. What do you think this point's going to be?
0, 1, 1.
0, 0.
120, 0.
0, 120. No. Raise your
Okay, we found our x-intercept, right? What's the y value for any x-intercept? 0, right? So we have this right there, ordered pair. Our y has to be 0. So we found x. We can't just get that randomly, so that goes right there.
How long is this bridge?
So, it's 120 feet.
20 feet long.
Yep, so from this point,
It's right
this
under the
point.
edge.
I'll draw that.
Mr. Conlon,
Yes.
so on the other side of the paper,
Hmm.
we only got 60, 36, and then on the back of the paper, you thought you had 60. So on the front, is it supposed to be 120?
Nope.
Then where did we get 60?
We got 60, so
Because we were dividing by 0.02 instead of 0.01.
this point right here, 60, 36, its x value is 60, right?
No, she's concerned about negative 1.2 divided by point.
Up there.
This right here.
She thought it was the same division problem. Why did it
Oh.
become 60 on the front and 120 on the back? Because
Oh.
we were dividing by 0.02 on the front.
I thought we were supposed to have the same thing on the back, like that's what we were supposed to be the answer, you know?
Now, we have to find the x-intercepts for Marco's plan. And this will be a whole lot easier because we're given a graph for it. So, where or what is the first x-intercept that you guys can see from that graph? 0, 0. And what's the other x-intercept that you guys see? What was that again? 100, 0. So we have an x-intercept of 0, 0. We have another one of 100, 0. So how long do you think Marco's bridge is?
100 feet long.
100 feet long. So Marco's,
I think we need that right here.
so we found the length of Rosetta's Bridge and the length of Marco's Bridge. Make a comparison between the two.
What is, Rosetta's, bridge is longer by 20 feet.
Okay, so I'm just gonna put a box, because this is our comparison statement. Rosetta's Bridge is how much longer than Marco's Bridge, did you guys say? Oops, bridge. How much longer? You guys are mumbling, I can't hear you.
20 feet longer.
20 feet longer. Alright. Alright. Last thing, third way that we can compare quadratic equations is by finding average rates of change over an interval. So for this one, the problem in our book says over the interval 0 to 20. So what do you guys think that means?
We're finding distance.
No. We're finding average rate of change, but over this interval 0 to 20. So what we're trying to find is on Rosetta's Bridge, at the starting point, we go 20 feet out and go up to the point on the bridge. What is that rate of change? So from the starting point to 20 feet on the bridge,
You want us to know how high we're gonna, is that what it's saying?
nope, we're trying to find where we start on average to get to the point on the bridge. How high are we going up?
10? I don't know.
We're actually trying to determine, since it's rate of change, what is this measured in? Is it measured in feet? Okay, and it's measured in, what else? What else is involved in this? Feet and what else? Look at Marco's graph. Does it tell us? No? Okay, so if we're doing rate of change, we're trying to determine how quick, how many feet it's going up
Per second.
over that interval, okay? I don't know what it's per, I guess.
You don't want us to use time.
Alright, so when we find rate of change over intervals, all we're gonna do is substitute our first number, 0, and our second number, 20, into an equation that we're given. So we're gonna have two separate ones. And 0 squared plus 1.2 times 0. Then we have our second one. That's not a 1. I think that's where the
So is the one on the left just gonna be, end up being 0?
Hmm?
Is the one on the left just y equals 0, is that what's gonna just end up being?
Well, 0 squared is 0, right?
Yeah,
We're
Anything?
solving for y, Troy.
Yep.
that's what I said.
We're solving for y, so anything times 0 is 0. Same thing over here. 0 plus 0 is 0. So for this one, we get y equals 0. On the other side, we have math to do. So,
Put that in your table, that show mark in the table.
okay, so we got y, x of 0. We got a y value of 0 for that one.
1.2 times 20, who's got it?
Okay.
I have a little suggestion here because we're running out of time.
Yeah.
Okay? So we're going to stop in the notes right here, but here's what you're gonna do, okay? For the everybody got a sheet of this paper. And you're gonna have homework, but you're just gonna, this homework's gonna be extended over 2 days, okay? So here's what you have to have done for tomorrow. You're gonna do those 3 problems, you're gonna do the first 2 steps, the things we completely got through in the notes, the green and the blue. We got through the green,
You go back down.
Oh, yeah, sorry.
and we'll catch back up tomorrow, okay? We'll come back to that tomorrow, if you want. We're not gonna worry about the yellow section right now. Okay, we'll come back to it tomorrow. You guys-
Wait, hold on. So
Well, listen carefully, Trey, let me just
No,
stop.
no, I have a question. Like, I don't know what you said. So we'll probably get done with this because this is gonna take us 5 minutes to finish in class tomorrow. So then we'll finish the homework. So are we gonna have another assignment to do?
Okay, right now, we're just gonna worry about what the assignment is for tomorrow, Trey, okay? The assignment for tomorrow is, that assignment over there, 3, 7, and 10. 3, 7, and 10. And you are going to do the first 2 parts, the 2 comparisons. What's the first comparison? Comparing their what? Their maximum or their minimums. And then you're gonna do the second comparison. What's the second comparison you're gonna make? Finding the distance between the x-intercepts. So you're gonna do those 2 comparisons for problems 3, 7, and 10. So everybody clear what the expectation is for the homework for tomorrow? Okay. And these notes come back